My name is Professor Phil Withers. I'm Director of the BP International Centre for Advanced Materials and Co-Director of the Manchester X-ray Imaging Facility, which is where we are today. The X-ray Imaging Facility is really all about collecting 3D images across a range of scales, and also across a range of time scales, so that we can study dynamic processes. For example, we can study how corrosion causes a gradual decrease in properties as the corrosion grows. We can study how materials degrade under loading, and we can even study how materials repair themselves. So it's that ability to look in 3D, but also over time, that's really important here in this facility. Our work impacts on a wide range of sectors, especially those where failure is unacceptable, for example in the nuclear industry or in aerospace or in oil and gas, understanding how materials degrade so that we can make them perform better and we can make them safer, but also in biomaterials where we're looking at the development of new materials for bioimplants so that we can make prostheses that behave in improved ways. The XRadia kit gives us a window into behaviour across a very wide range of scales, and so it's providing information we just can't get in other ways. In particular, the XRadia equipment is very well tuned to study experiments in situ, to study degradation as it happens, not to take lots of sections and to follow it afterwards, but actually to see things in real time in 3D. What's special about the Versa is it attacks the sub-micron length scale. There's an awful lot of material science occurs at that length scale. And furthermore, it will have the capacity to take large pieces of equipment so that we can see behaviour in situ. One of the great things about the Versa is it allows us to study a huge range of materials, from steels right down to skin. So we have a fantastic opportunity to do new experiments and to see things that no one has seen before. Being able to get information more quickly is important for a whole range of reasons. Our machines are used 24 hours a day, so it enables us to do more science, but it also enables us to study over timescales that are shorter than the ones we can look at with our current systems. One of the great things about the XRadia equipment is that it's sensitive to phase contrast and not just attenuation contrast. Attenuation contrast is the kind of contrast you get in a normal X-ray radiograph between hard materials like bone and soft materials like tissue. But if you want to see very sensitive changes, then you need phase contrast. And fossils can require very delicate imaging, and we can get images from our XRadia system using phase contrast that you just couldn't hope for using traditional imaging means. Auxetic materials are materials that when you pull them one way, instead of contracting in the other, they actually expand in the other direction. Now this is a whole new class of materials with exciting properties, but we are able to study the microstructures within these materials that gives rise to this unusual performance. And the whole aim is to be able to engineer in materials that respond very precisely to expansion in one direction in the other direction. This might be to make materials that deploy themselves so that when you pull them in one direction, they deploy to take up a shape in another. And it's only by understanding the relationship between the microstructure and the expansion that we can engineer those materials, and our machines are giving us those insights. So our new Versa will provide information at the sub-micron scale, but it's the ability to image at different scales that's really important. If you want to understand how structures work, you need to understand them at the nanometer scale, you need to understand them at the micron scale, and you need to understand them at the millimeter scale. This machine is our NanoCT machine, and it is currently the highest resolution X-ray 3D imager in the UK, and it provides us with insights at the 50 nanometer length scale, and it has optics which are unique at the moment in the UK. One of our big areas of interest at the moment is understanding materials that are able to heal themselves. And in order to get that healing right, we need to be able to understand the relationship between the environment and the triggering device that causes them to heal, whether that's exposure to air or a particular temperature or a particular load. That's one of our key areas at the moment. Another one is understanding rocks and flow through rocks. This is very, very important in terms of understanding our extraction of oil and shale gas, which is an area of big importance for the energy industry at the moment.